it's finally time to announce the results of my translation comparison survey. Before I do, I want to thank everyone who has participated in this project, including all the translators and the respondents who took the time to read 6 pairs of passages. Also, I will make a separate video to look at the comments that the participants made for each text, but that's going to come out after my first Q&A video. This video is going to be structured as follows. If you want to skip to a particular section, you can find timestamps in the description below. 1. The hypothesis. 2. The design of the survey and limitations. 3. The selection of text. 4. The demographics of the participants. 5. The results and graphical analysis. 6. Stats. And 7. Concluding remarks. Section 1. The hypothesis. The hypothesis that I wanted to test through this survey was the following. There is a significant difference between how people rate the naturalness of text translated by Google Translate and how they rate the naturalness of text translated by DeepL Translator. Section 2. The design of the survey and limitations. To be able to test this hypothesis, I had to come up with some ways to measure the naturalness of text. So, in the survey, I asked the people to rate how natural each piece of translation sounded to them on a 7-point Likert scale, with 1 being very unnatural and 7 being very natural. I believe this is the most straightforward method of collecting judgments of naturalness, but I do have to mention 2 potential issues. First, the concept of naturalness is imprecise, and therefore people are likely to have different ideas of what makes a text sound natural or unnatural. In the survey, however, I didn't define the concept for them, nor did I ask them to define it. So it is quite possible that this question might not have been successful in probing the same underlying construct across different respondents. I could have provided the respondents with separate scales for different aspects of text that contribute to their naturalness or unnaturalness, such as grammatical accuracy, lexical choice, and coherence, but this would have actually compounded the problem because the concepts such as grammar, choice of vocabulary, and coherence are also imprecise and could be interpreted differently by different respondents. Even if I had defined the concept of naturalness and given them a set of criteria for judging the naturalness, there's no guarantee that every respondent would have understood and agreed with my definition, or that they would have followed my instructions. In any case, I strongly maintain that not giving them even more text to read was the right choice because many people found this survey too long and were not able to complete it. Second, the nature of ordinal data obtained by means of a Likert scale is such that there is no way to establish whether the psychological distances between the points on the scale are all equal within each respondent as well as across different respondents. For example, are the distance between 1 and 2 and the distance between 2 and 3 the same within respondent A and between respondents A and B? Since the naturalness ratings could be problematic, I decided to include another measure of naturalness. I asked the respondents which text they believed had been translated by a human translator, and they had to choose one of the 4 responses: both, 1, 2, and neither. I didn't mention in my survey how many of the texts were machine translations, or even the fact that I was comparing Google Translate and DeepL, though my viewers should have been aware of the purpose of this survey. Moreover, I strongly believe that this question, unlike the previous one, was straightforward enough that no one misinterpreted it. Section 3. The selection of texts. The English version contained only text translated from Japanese, while the Japanese version contained only text translated from English. The versions in the other languages contained the first 3 texts translated from English, as well as the first 3 texts translated from Japanese. The English version had excerpts from the following texts. 1. デビットカードの作り方 taken from the website of Rakuten Bank in Japan. 2. The Japanese Wikipedia entry on プロトタイプ理論 3. 我が輩は猫である by the Japanese author 夏目漱石 4. 竹取物語 written sometime between the 9th century and the 10th century by an unknown author in Japan. The text was in original Old Japanese. 5. One article of 道路交通法 and 6. A plot summary of Wonder Woman 1984 taken from eiga.com, a Japanese film review website. The Japanese version had excerpts from the following texts. 1. How to teach overseas, an article taken from WikiHow. 2. The English Wikipedia entry on Thalassius, a type of bird. 3. Moby Dick or the Whale, a novel by the American author Herman Melville. 4. Act 1, Scene 1 from Macbeth. The text was written in the original Shakespearean English. 5. A section of the New York State traffic law. And 6. A plot summary of Greenland, a movie from 2020, taken from the popular movie review website. Section 4. The demographics of the participants. As of recording this video, 36 people participated in this survey. All of them were native speakers of the languages they took the survey in. There were 3 speakers of German, 20 speakers of English, 1 speaker of Spanish, 3 speakers of French, 2 speakers of Italian, 1 speaker of Japanese, 2 speakers of Polish, 2 speakers of Portuguese, and 2 speakers of Russian. Next, let's look at the age distribution. 23 people were in their 20s. This was expected because the majority of my viewers belong to this age group. Next, the participants also reported their educational backgrounds. 15 people completed up to secondary education, and 11 people had bachelor's degrees. Another question I asked in the survey was how many foreign languages the participants spoke at a conversational level. Well over half of the participants spoke 2 or more foreign languages. Section 5. The results and graphical analysis. Each of the 36 participants rated the naturalness of 6 pairs of translated texts using a 7-point Likert scale, meaning the dataset contained 36 times 6 times 2 or 432 judgments. Here's the distribution of the ratings. This histogram shows that the ratings between 5 and 7 were more frequent than the ratings between 1 and 4, indicating that they were a good chunk of translations that sounded more natural than unnatural. Each of the participants also rated how familiar they were with the topic of each text. This is the distribution of the familiarity judgments. The ratings between 1 and 5 were roughly equal in frequency, but the ratings of 6 and 7 were more frequent. Furthermore, each participant judged whether each piece of translation had been translated by a human translator. A decent proportion of the texts were able to fool the participants into thinking that they were human translations. Nevertheless, the participants were approximately 1.6 times more likely to say that a given text had been translated by a machine rather than by a human. Next, let's look at how each of the texts was judged in more depth, starting with how to make a debit card. This is the overall distribution of naturalness judgments for this text. As you can see, this is a left-skewed distribution. The mode is 6 with the frequency of 20. If we look at how the 2 translators performed, DeepL obtained better ratings than Google Translate. This text itself was slightly more likely to be judged to have been translated by a machine, but the translation by DeepL was more likely to be judged human, whereas the translation by Google Translate was far more likely to be judged machine. For the rest of the text, I will only show you the comparisons between the 2 translators, to save you time. I'll make a comment only if something irregular is observed. The text, "The Tale of a Bamboo Cutter," was clearly an anomaly because both translators performed very poorly. This is likely due to the fact that the original text was written in Old Japanese. Still, it has to be noted that the translation by DeepL was able to convince 5 participants that it was a human translation. The text fallacious was another anomaly because DeepL performed worse than Google Translate in terms of both naturalness and human versus machine judgments. The text Moby Dick was another anomaly. DeepL didn't perform as well as it did in the other texts, though Google Translate performed poorly, as usual. There were also 3 texts that were only included in the Japanese version, but since there was only one Japanese participant, I will skip the analysis for these 3 texts, though they are included in the overall results. Having seen each of the texts, let's look at the aggregated results. This graph shows the aggregated naturalness ratings for each translator. Looking at the graph, I can say that it is very clear that DeepL had more ratings in the 5 to 7 range than Google Translate did, whereas Google Translate had more ratings in the 1 to 3 range than DeepL did. Therefore, overall, DeepL seems to have performed better than Google Translate in terms of naturalness ratings. Here's another graph, which shows the aggregated human or machine judgments for each translator. We can see that the translations by DeepL were more likely to be judged human than machine, while those by Google Translate were far more likely to be judged machine than human. Therefore, in both measures of translation naturalness, DeepL seems to have performed better than Google Translate. Section 6. Stats. To see whether the naturalness ratings differed significantly between the 2 translators, I performed ordinal logistic regression. I chose this method because the outcome variable, i.e. naturalness, was ordinal. To be justified in using ordinal logistic regression, I had to ensure that the proportional odds assumption or the parallel regression assumption was not violated. According to an article by the Institute for Digital Research and Education at UCLA, this assumption means that, to quote, "the relationship between each pair of outcome groups is the same." In other words, ordinal logistic regression assumes that the coefficients that describe the relationship between, say, the lowest versus all higher categories of the response variable are the same as those that describe the relationship between the next lowest category and all higher categories. To test this assumption, I performed the Brant test, originally developed by Brant, on the regression models obtained by the POLR function, included in the mass package in R. The only predictor variables that I was able to include in my models without violating the assumption were the translator variable, the human or machine judgment variable, and the familiarity variable. Since the output of the POLR function didn't provide an easy way to check the goodness of fit of the model or the marginal effects, I switched to using a different package called OGLMX. I used the OGLMX function within this package to obtain a model using the same 3 predictor variables. The goodness of fit of the model, as measured by McFadden's R-squared, was 0.1856518, which doesn't indicate a particularly great fit, as a value between 1.2 and 1.4 is generally considered an excellent fit. However, my aim isn't to construct a predictive model, but only to test my hypothesis, stated in section 1 of this video. Therefore, what really mattered was that the translator variable was in fact found to be statistically significant at an alpha level of 0.05 with the coefficient of -0.9, the standard error of 0.2, and the p-value of 2.8 times 10 to the power of -6. Moreover, I checked the marginal effects of this variable for each of the 7 naturalness levels using the margins.oglmx function. Marginal effects tell us how the outcome variable changes with respect to change in a given predictor variable. I won't go into much detail, but the marginal effects of the translator variable were statistically significant for each level of naturalness. Next, let's look at the relationship between the translator variable and the human or machine judgments. Based on the graph we saw in the previous section, it is already very clear that translations by DeepL were more likely to be judged human than those by Google Translate. To explore the relationship between two categorical variables, we can first construct a contingency table. The table tells us essentially the same information as the graph. When you have a 2x2 contingency table, you can use statistical tests such as Fisher's exact test and chi-squared test, or we can calculate an odds ratio. First, I use the Fisher.test function to perform Fisher's exact test. The p-value was 2.2 times 10 to the power of minus 16, which is an extremely small value and is certainly small enough to reject the null hypothesis that the odds ratio is equal to 1. The odds ratio was in fact 6.65, which is well over 1, and the 95% confidence interval was between 4.2 and 10.7, which doesn't include the value of 1. Second, I also performed a chi-squared test, just for fun, using the chi-squared.test function. The value of chi-squared was 75.9, and the p-value was the same as the value obtained in Fisher's exact test. To check the effect size, I calculated the value of Kramer's V using the Kramer's V function included in the package LSR. The value of Kramer's V was 0.41. A value between 0.3 and 0.5 is considered to indicate a medium effect size. Both tests agreed that DeepL performed better than Google Translate in terms of the odds of being judged human as opposed to machine. Section 7. Concluding remarks. I spent way too much time on this project, and I honestly want to move on to the next video. All I have to say is that, as expected, DeepL is better than Google Translate. This project has many limitations. First of all, many people thought the survey was too long, resulting in a small sample size and the relative lack of non-English speakers. Secondly, the naturalness judgment, or the use of a Likert scale, may not have been ideal. Due to the nature of ordinal data, the naturalness ratings were difficult to analyze and interpret. Finally, I wanted to explore the effects of some other variables, such as the familiarity ratings, educational backgrounds, age, and text genres, but this was outside the scope of this project. Thank you for watching.